All right, in this question, we're just trying to figure out our delta H's for these reactions. If we look at our formula for delta H, we're going to use it for both of them. I'm just going to write it once on here. And our delta H is equal to the sum of my H naughts for my products minus the sum of my H naught for my reactants. And those numbers are going to be pulled right from our reference guides. So these are my, over here, these are my products, these are my reactants. So to make sure that the chemical equation is balanced, we've got one lead on each side, one oxygen on each side, one carbon on each side, so we're good. And now I'm just going to take the values in my tables for everything that I need. In this case, for carbon monoxide, it's negative 110.5 kilojoules. And for any element in its natural state, in this case lead as a solid, it's going to be 0, so we don't have to worry about that. And then the same deal with our carbon. So now we're going to subtract from that the delta H of our lead oxide, or lead 2 oxide. And this turns out to be negative 217.3 kilojoules, and we don't have to worry about the carbon there. So if we do this, we find our delta H is going to be 106.8 kilojoules. It's positive in this case, so that means it's going to be endothermic, so the reaction is going to require energy from the surroundings. If we look at this next one here, the only one that we're not going to have to worry about is these 3 O2s. That's the way oxygen is in nature. So the delta H for any element in its natural state is 0. So let's take a look at our sulfurs. So it's going to be 2 times sulfur dioxide. And if we look into our reference guide, it'll be 241.8 kilojoules. And we're going to add to that 2 times the mass, or 2 times the delta H for water. Be careful because this is gaseous water, and a lot of people make the mistake of putting in the value for liquid water, and that's going to be negative 296.8. And then now we're going to sum that side, and then from that side we're going to subtract the delta H's from our 2 H2S's. That's going to be negative 20.6 kilojoules. All right, so when I do the math here, I should end up with delta H of negative 1036 kilojoules. And that's how we do these problems. Real simple. Just get your numbers right out of the review guide, the reference guide. I'll make sure that if they aren't in there, I'll give those to you on the test or quiz. And when we get to number 10, we'll see that the numbers you need actually are not in the review guide.